right, so last night for homework you had page 119 and you had 9 and 11, yes?
Yes.
Those of you who weren't here, I did share the notes and everything with you on Google Classroom. Okay, so number 9 says, the graph shows the number of boxes a machine packages over time. Is the relationship proportional? How many boxes does the machine package in 4 minutes? Okay, so the first question, is it proportional? Okay, so I have a yes. How many yeses do I see? Okay, how do we know that this relationship between the time and the number of boxes packaged, how do we know looking at the graph that it's proportional? Danica? Very good. The graph is a straight line. And goes through the origin. Okay, so it meets both our criteria, right? Okay, we talked about that yesterday. For a graph to be a proportional relationship, has to be a straight line, has to go through the origin. Okay, so the second question is, how many in 4 minutes? Okay, so how many packages does the machine box in 4 minutes? Craig? 100. Okay. Craig, how did you figure that out? Okay, so because we know it's proportional, can we just look at the graph? Yeah, we can just look at the graph. What if we can't determine the value just from looking at the graph? What do we need to do then? Yes? Very good. We need to find a point. So we need to find the constant of proportionality, write an equation, and then move forward. Sometimes we're going to be able to look at the graph and determine our value, which we could do on this one. But we couldn't do that on this one that we did yesterday. So we did have to walk through the steps of finding the constant of proportionality, writing the equation, and then inserting our value. If you can look at the graph, why worry about the constant proportionality in the equation, right? So that is something that we are able to do in this situation. All right, any questions on number 9? This room is extremely hot, correct?
Yes.
Because today I'm just wearing a light dress and I'm still hot. And I keep on thinking it's because I'm pregnant, but it's not right. It's not just me, right? You can move these back, guys. Yeah, go ahead. Open whatever you I'm dying right now. Okay, number 11. Number 11, the graph shows a proportional relationship between the cups of flour a baker uses and the number of cookies made. So, letter A. What does the point 0, 0 represent in this situation? Zach, go ahead. Okay, so it is the origin, but what about this situation specifically? Shane, go ahead. Very good. So in this situation, it is the origin. I agree with that because it is the point 0, 0. But in this situation, 0 cups of flour for 0 cookies. Is that reasonable? Yes. Absolutely, it's reasonable. If I don't have any cookies, I don't have any flour. If I don't have any flour, Okay, so that is reasonable for us. All right, letter B. What does the point 118 represent? So what does the point 118 represent, Bob? Okay, very good. Excellent. 118 is the constant of proportionality. Excellent. What does it mean in this specific situation? You are absolutely correct. I love it. Constant proportionality, that's our point. So we need to remember that anytime we see a 1 and then a value on our graph, that's our constant of proportionality if the relationship is proportional, correct?
Yes.
All right, Danica, what does 118 mean?
It's 1 cup of flour for every 18 cookies.
Very good. So 1 cup of flour for 18 cookies. Very good.
I said it's unit rate.
Okay, unit rate, is that the constant proportionality?
Yes.
Yep, I'd accept that, absolutely. Okay, any questions on 9 or 11 homework? All right, so let's go ahead and look at, so we're going to go ahead and finish up our notes. So page 117. Okay, so on page 117 in our volume 1 books. So we're going to look at interpreting graphs of proportional relationships, as well as what do proportional relationships look like and what do non-proportional relationships look like. So that's what we're going to focus on today. So the graph shows a proportional relationship between the distance and the amount of time Mr. Brown drives. So looking at our graph, there's some things I want you to notice. We've got a title, Mr. Brown's road trip. We've got our independent variable, which is our x-axis, which is the time in hours. Yes, dear?
Is our x the independent variable?
X is always independent. Yep, absolutely. And then our y here, that's our dependent variable, which is our distance in miles. So just looking at the graph, what are some things that you notice? Okay, so what are some things that we notice in the graph? Go ahead, Tucker.
Straight line is proportional.
Okay, it's a straight line, and goes to the origin. So we know this about the relationship. It's proportional. It meets both of our criteria. Straight line and goes to the origin. So we know it's proportional. Craig, go ahead with something else.
It gives us COP.
Okay, it gives our constant of proportionality. We know how fast Mr. Brown is going in 1 hour. Could we then write an equation to model this situation if we know the constant of proportionality? Absolutely. If we know K, we can write an equation that models the situation. Yes, dear? Oh, okay. All right. So it goes to the origin. It's a straight line, so we know it's proportional. We also know that the constant proportionality is 155. So that means in 1 hour, he goes 55 miles. So then, what does the point, so we know 0, 0, 0 hours for 0 miles, correct? We know 155, which is 1 hour for 55 miles. What about 5, 275? What does that point represent on our graph? Mace, go ahead.
It's on 5 and it goes all the way up to 275.
Okay, so our graph, we start at 5 here, we go over 5 and then up to 275. Okay, so what does that mean for Mr. Brown?
That's like
What?
that's the time.
Okay, 5 hours he drove and he went.
275.
Very good. So 275 miles in 5 hours. Okay, so 0, 0, Mr. Brown drives 0 miles in 0 hours. 1, 5, Mr. Brown drives for 55 miles in 1 hour. And then 5275, he drove 275 miles in 5 hours. So what's the constant proportionality? 55, very good. So K equals 55. When our Y coordinate is 1, our X coordinate is always the constant proportionality. So when our X coordinate is 1, our Y coordinate is the constant proportionality, anytime. If the line is straight and it goes to the origin. Okay, so it's got to meet those two things before we determine constant proportionality. So, if we know the constant proportionality is 55, what's the equation that models our situation? What's the equation that models our situation about Mr. Brown's driving? Gabrielle, thank you, honey.
Y equals 55x.
Y equals 55x. Very good. Okay, so that's what we're looking for. We know constant proportionality. We just plug it in for K into our equation. Okay, that tells us how fast he's going in 1 hour. Then we can find 2 hours, 3 hours, 4 hours, 10 hours, just by using that value of x. All right, so let's look at our try it. Suppose the graph of Mr. Brown's road trip is extended. Find the ordered pair with an x coordinate of 7. What does this point represent in this situation? So we want an x coordinate of 7. So if we have an x coordinate of 7, what does 7 represent? What does 7 represent in our equation? Casey?
The time.
The time, very good. The amount of hours he's going to be on the road. Okay. So what we can actually do is we can use our equation. Okay. This is the amount of miles he drove. This is the amount of time he spent on the road. So our x coordinate is going to be 7. So we can plug 7 into our equation. Once we plug 7 into our equation, we can figure out, okay, 7 hours he drove this amount of miles. Tucker, you had your hand up, hon?
No,
What?
I was.
Oh, okay, I'm sorry. What?
I have 3 as
385? Everyone else agree?
Yep.
What does 385 represent? The number of miles. Very good. So 385 miles. Okay, so that means that our point of 7, 385, means that Mr. Brown drives 7 hours. Are we seeing how our graph, our constant proportionality, our equation, we see how everything's meshing? Okay, yes, yeah.
Like on the test, would you give off points if we just wrote y equals 385?
I usually like a context of it. Would I take off points? Not necessarily, because actually on the state test they don't require you to label. What on the state test it would look like this. If it was a fill in the blank, it would look like this. Okay, so they're giving you the measurement. All you would have to write in is the actual mileage. That's 385, not 285. So I don't usually, when I grade your test, if you notice, I don't take off for labeling, but I will put in miles after it, so you understand, so you see that visual, so you know what it actually represents.
Isn't that like a big thing when you get like algebra and stuff like that? You have to like label.
Yeah, because teachers like in previous years have been
Yeah, you should always label. I mean, I'm not denying that you shouldn't label things, because you need to know like the context of the problem, right? So you need to understand what 385 represents. And that's why I always ask 385 miles. I'm not debating or disputing that you should label, but I'm not going to take off points. You did the problem correctly. I'm not going to take off points because you didn't label. You obviously know how to do the math, right? As far as algebra is concerned, labeling, yeah. Geometry is a big one to label. Geometry is the big one that you need to label because we're talking about specific units, angle measurements and, squared versus cubed. So there are things that, that you should label. That's not the hill I'm gonna die on though. It's just not, I mean, dude, if you can do the math, I'm okay at this point, So, I want you to label? Absolutely. Am I gonna take points off for it? No. Okay. Good question though. And especially if they don't. That's why, I always, for the longest time, the state test required kids to convert improper numbers to mixed numbers. And if the problem was in fractions, then the answer had to be in fractions. So I was dying on that hill when I first started teaching. When they changed that of the test, I don't care what form you give it to me in, right? It's a fraction, a decimal, proper fraction, improper fraction, whatever it is, an equivalent fraction, I take the answer. Because you know how to do the math and you understand the concept of it,
Okay, so what you're saying is on the state test, if the answer was 88 fifths or something like that, you could just write 88 fifths.
Absolutely. Yep. Unless they ask you for a specific,
That's fine. I remember there was one question a couple years ago. It was 9 over 4. It took so long to do that. I had to convert it all the way down to improper.
right. So the things that I would look for in that situation, money. If it's a problem about money, are you writing the fraction form of that? No, you need the decimal form because you need, you need dollars and cents, and you need it to be rounded to the nearest hundredth. As far as a fraction goes, any form would work. But then again, let's talk about the context of the problem. If it's money, it needs to be in money form. So those are the things I to think about when you're answering those kind of questions. All right, so let's go ahead and look at these three. Okay, so this is example number 4. We're still on page 117. Explain why each graph does or does not represent a proportional relationship. Okay, so what are the two things that has our criteria? What are the two things that has to meet? Zach, give me one. Has to be a straight line. Someone give me another one. Casey? Has to go through the origin. So those are the two things we're looking for. If it meets one, is it proportional?
No.
It has to meet both. Okay, so in your mind, that needs to be your mental checklist. Yep, straight line, check. Goes to the origin, check. That's proportional. So we need to have those 2 check marks. So let's look at this first one. Straight line,
Yes.
goes to the origin.
Yes.
So what kind of relationship is this? This is a proportional relationship. Very good. Okay, what about this one? Straight line?
Yes.
Goes to the origin?
No.
So what kind of relationship? Origin? Straight line?
No.
Very good. Okay, so this one here. Draw draw two graphs that pass to the point 2, 3. One that represents a proportional relationship and one that does not. Label your graphs as proportional or non-proportional. Okay, so it's got to go through the point 2, 3. And one has to be proportional and one has to be non-proportional. So I want you to do that right now. Okay, so do your graphs have to match Brooke and Hope and Bailey's?
No.
No. Okay, so Hope, why did you choose to draw that? What made this proportional to you?
How to do the straight line and the origin.
Okay, very good. It had to be a straight line, it had to go through the origin. Is there another line that we could have made for this?
No.
Not really, because it has to go through the origin and it has to go through the point 2, 3. So the majority of yours, I'm sure, looked very similar to this line, correct? Now, proportional or non-proportional, which Bailey did, yours could vary quite a bit, right? So Bailey's started 2, kind of curved up, and then went straight. Obviously non-proportional, right? It's not a straight line, doesn't go through the origin. I saw a lot of different ones. I saw this one. Okay. Straight line, but doesn't go through the origin. I saw this one here. Okay. You can even do this one. Just straight across. Okay? Those are all non-proportional relationships. Don't go to the origin, not a straight line. Those are our criteria that we're looking at. Okay? Excellent job today, ladies and gentlemen. All right, so for homework, pages 118 through 120. Sounds like a lot, but it's really not, I promise. I want you to do four through 7, 8, and then I want you to do 14 and 15. So that's 7 problems. Okay, so 4 through 7, you're looking at the same graph and you're answering, well, you're looking at the same scenario. So you're going to have to graph and then interpret some of the problems or some of the things from the graph. Number 8, you're telling non-proportional or proportional. And then 14 and 15 are assessment practice questions. Okay, so you have quite a bit of time to start your assignment, yes?
Yes.
Okay,